Hello, everyone. Today we are two people presenting this talk. I am an astronomer in Chile, and Javiera Núñez, who is a physics teacher and who presents this work as her final dissertation to obtain the physics teacher degree. As a motivation of this work is that Chile is one of the most important countries to develop astronomy research. However, the content of astronomy in the curriculum is scarce and fragmented, as was demonstrated by a recent study published by Rodriguez during this year. Since 2022, the CIRAS Center at USACH created a pedagogical team composed of astronomers, high school teachers, and science education specialists in order to conform to a professional learning community, which is centered into collaboratively co-create didactic sequence using real astronomical data to incorporate frontier astrophysics into the science subjects of the high school level. This team has created a lot of didactic sequences to teach in subjects such as mathematics, physics, chemistry, and also biology. All these activities have been implemented in the School of the Teachers teams to validate the disciplinary and pedagogical content of the proposal. This work has been preliminarily demonstrated by a change in the students' perceptions about the scientific work. However, this educative material is not ligated to a validated instrument to measure the impact of working with astronomy real data in the classroom. To test if the didactic sequence based on the real astronomical data works, we search in the literature. However, most of the instruments are related to measure level of knowledge related to fundamental astronomy at a school level. Last year, the IAU launched the Evaluation Framework at Toolkit, which contains a theoretical basis and tools to collect data to evaluate activities that use astronomy for the education, and also guidelines on ethical concepts for the collections of data from astronomy activities for education. Different types of tools appears in this manual. The use of each depends on the objective of the activities, the audience, the format, the time, and the resources available. Based on the suggestion in the manual, we decide to use the questionnaire in pre- and post format to measure the impact of using real astronomical data in the classroom. We base the creation of our tool on the astronomy and student attitudes, or also called ASA questionnaire, created by Bartlett et al. 2018, which is suggested in this manual. This questionnaire is an instrument to measure students' attitudes toward astronomy and science, where it assesses 8 main categories: interest in astronomy, interest in science outside school, hands-on work in science, teacher actions in science, perception of science ability, future aspiration in science, benefit of science, and personal relevance of school science. Our test is a combination of questions from the ASSA test and our own test. And it is in the form of pre- and post-test for comparison. The methodology is mixes with questions in the Likert scale format, open and closed, so that the data allows both qualitative and quantitative analysis. In designing the tool, we first incorporate the ethical protocols suggested in the manual for collecting data from students in the classroom. This states that participation in the survey is voluntary and that the information collected will be kept confidential and used only for research purposes in the field of astronomy for education.
The categories of questions are based on the ASSA instrument, and they are student characteristics, perceived abilities in science, perceived interest in astronomy, practical work in science, future aspiration, and feedback. Examples of the question are shown in the table, both for the pre and post. To validate the instrument, we apply validation by expert judgment, which measures variables as sufficiency, clarity, coherence, and relevance, based on the criteria established by Escobar Perez and Cuervo Martinez 2008. So far, we have contacted 4 experts from areas of work such as science education and physics teaching. Their academic profiles are shown in the table. So far, we have only managed to connect with science teachers, but none with a specialization in astronomy didactics, as this is still an emerging area in Chile. The judges' level of agreement was not high, mainly because they found the test contained very general questions. However, we believe that this test should be with general questions, as it is expected to be applied at the end of very varied activities and different science subjects at secondary level. In addition, we conduct preliminary validation by classroom implementation. Preliminary results of the implementation have shown that the activities generate a change regarding, for example, the student's perceptions of the relationship between physics data does indeed help them to better understand the subject matters of the physics class.
Well, finally, in conclusion, this work needs to go through further validation process before it can be considered as a tool to be applied to any activity using real data in the classroom. We hope to have a large number of judges who can review these tests, and since we don't have many specialists in Chile, we leave the invitation open so that the OAE can help us in this process. In addition, we are in the process of collecting data based on the implementation of a physics guide that uses Kepler's third law for exoplanet. In this way, we hope that next year we'll have enough information to launch this instrument so that any educator in the world can apply it in their classroom. So that's all. Thank you for your attention.